Our experiment today is the non-disruptive test. First of all, we're going to start with the ultrasonic. First of all, we're going to do a calibration for the machine itself. When we put these two together, we should get a zero reading. Yeah. With using this item, we should get a 25.9 after we put the gel on both the sides. We get almost the 25.9 microseconds.
We will prepare the sample for our test. First of all, we will make a cross in the top of the head and cross in the bottom to put the two devices for the ultrasonic on both of them. And now I will make the cross.
So, first of all, we have to make sure that this device is calibrated. So after we make sure, we're going to take now the distance. We're going to take 3 dimensions and we'll take the average of them. So the first one was 150.16 millimeter. And the other one is 150.21 millimeter. (149.91 millimeter). Now we're going to take the time that it takes the machine that will take. We should make sure to put the two devices on the same side. It's fine. The reading is 033.9. 32.9. And we're going to take the second reading now. It's 34.6. And now we're going to take the last reading and we'll take the average of the 3 readings that we just took. The reading is 33.5. Now we're going to do a calibration for the Schmidt hammer with the using this device. It's called the Anvil, sorry. Now the reading was 97, and we can take it as a right reading because in the Anvil we have 80 plus or minus 2.
We will use this paper here, which has 16 dots for the Schmidt hammer device. Now we will prepare the dot for the Schmidt hammer device. As I said before, it's equal to 16 dots.
After the machine now is holding the cube, we're going to take the 16-point reading from the Schmidt hammer. So we're going now to start with the first one. after we did the Schmidt hammer, we're going to take the reading over here, and we're going to take the average of them, and any number above or less than 6 from the average, we're going to dismiss it. So we're going to take this normal graph over here, and according to that to the 38 reading, we're going to read it from this part.
Sorry.
And the reading is for 46 megapascal. This graph is for the 20 millimeter cube, and it's written here for the 150 cube. We have to multiply it by a factor 1.05 over here. So we calculate 46 multiplied by 1.05, and we get the 48.3. Today we're going to talk about this instrument, R meter MK3. It determines the depth and estimate the size of the metal objects inside the concrete. And now we're going to start connecting it. After we finish connecting it, now we're going to start setting the device. Now we're going to turn on the device, and by default it's going to start estimating the cover. But we can just go back, and either we can start the cover and the size of the steel.
But now we are going to choose the cover, and we're going to test it now. Depending on the rebar location, we are going to choose either short mode or deep mode. For this experiment, we are going to choose the deep mode. We also have to choose the material type. We have to choose the phi for the material and other characteristics depending on the steel in the concrete that we're going to test. And the last step to start the experiment, we have to go to this option, to this line, highlight, and then we have to press right, the right arrow, and then we have to press it another time. After that, we are going to start testing the device. You can see while moving the device, the peep sound is going to increase and decrease depending on this and the rebar size. As we're going, the peep is going to increase and decrease accordingly to the peep size, to the rebar size. The R meter MK3 can also locate the size of the bar. We can locate the size of the bar by choosing the option. After that, we can see through the readings that if we locate the device, the reading device, in the middle of the bar, the reading will be at the maximum. At that point, we have to press enter. Enter. After that, we have to put this block, which is 3/4 of an inch length, under the device, under the sensors, and take the reading again. After that, if we take the reading, the reading will be given. The diameter of the length would be given. This device is supposed to measure the corrosion in a steel bar. This device is called corrosion analyzing instrument. After connecting the device properly, we are going to connect the device directly to the steel bar, and we are going to add mix a chemical with the water, and then we're going to add the chemical to this probe. Most importantly, the probe, after taking the cover off, it's going to be moved along the steel bar, and after that the reading would be by pressing star. It's going to show us the darker the display, that means that we have corrosion in that specific position, depending on the values. You can take the readings according to the graph we have.